This one is an extract or a case study, and it reads as follows: South Africa's very own mountaineer and adventurer. Right, so they say Sibusiso Villani became a South African hero after summiting the Earth's highest mountain, Mount Everest, in 2003. He started training in mountaineering by climbing the peaks of the Drakensberg mountain. Ex-President Thabo Mbeki said the following on the summit day: "In this, he has shown the heights we can scale in life if we put our shoulder to the wheel. Sibusiso, you have done us proud." He continues to climb great peaks and throughout the world, and is actively involved in humanitarian work. Mountaineers like Sibusiso Villani put their body under severe strain or psychological strain when climbing up the heights of 8,000 meters. The higher the altitude, so let's highlight this because this is important. The higher the altitude, the greater the stress on the human body, the availability of oxygen decreases, and hypoxia, which is oxygen starvation, can set in. So we're talking about the heights of 8,000 meters, which therefore means that the higher you go, the oxygen availability becomes less. Oxygen availability becomes less, and this can lead to hypoxia or oxygen starvation. It literally takes your breath away. Average temperatures are well below freezing, so they decrease temperatures in the troposphere. So climbers can become disorientated, develop acute mountain sickness, and get frostbite on their extremities or extremities. Many climbers have died on Everest. Athletes in extreme sports like this will try and acclimatize to these adverse conditions by preparing their body for the psychological challenges. The Sherpas who assist climbers live at high altitudes all year round, and their body have adapted well to the low oxygen levels and adverse cold. This leaves us with words from one of Sibusiso's motivational speeches: "Every person has their own Everest to climb." So let's go to the questions there. 1.5.1, they say, now with low oxygen levels, what other atmospheric gas could become a problem in the system of climbers like Sibusiso? That is carbon dioxide. We know that carbon dioxide and oxygen during gaseous exchange, when you breathe in oxygen, you breathe out carbon dioxide. So if you have less oxygen being breathed in, it means more carbon dioxide is going to build up in your body. And like I said, remember, carbon dioxide, it is toxic, so your body must find a way to decrease it if ever it increases. So it is very much important for your body to remove this carbon dioxide. 5.2, how are the levels of the gas that you have given as your answer in 5.1 detected? They're detected by chemoreceptors in the artery. Chemoreceptors in the artery detect the decrease in the pH of the blood due to the increase in what? Due to the increase in carbon dioxide. Remember, carbon dioxide forms carbonic acid. Then 1.5.3, they say in a flow diagram. Well, you're not going to be asked a flow diagram. You'll be asked to explain in words. So let's see, in a flow diagram, show how their bodies try to compensate to adapt to the level of the gas in their system. Compensate and adapt to the levels of the gas in their system. So basically there's gonna be an increase in CO2 levels. This means that the pH drops, and then this pH, the chemoreceptors will detect the pH decrease, and what happens next? Chemoreceptors will send impulses to the medulla oblongata, oh, let's make more space then. I need room. The medulla will send impulses to the breathing muscles and cardiac muscles, the heart. There will be an increase, thus the heart rate and breathing rate will increase, then more carbon dioxide will be exhaled, or you can say removed from the body, and CO2 levels will decrease back to normal. So this can be an 6-mark question to describe this process. I'm just gonna go through it again just so you understand. Now, how does the body compensate when there is an increase? Well, this is the stimulus, by the way. This is your stimulus. The increase in CO2 levels will cause the pH to drop. This drop in pH will be detected by chemoreceptors, and the chemoreceptors will therefore send an impulse to the medulla oblongata. Then the medulla oblongata will respond by sending an impulse to the breathing muscles as well as the cardiac muscles, and thus the heart rate and the breathing rate will increase. The heart rate, of course, it increases because more blood will be pumped to the lungs, and the breathing rate will also increase because more carbon dioxide has to be removed. So more carbon dioxide will be exhaled and removed from the body, and thus the carbon dioxide levels will decrease back to normal. And that's how you explain homeostatic process of carbon dioxide.